Hello everyone, hope you are doing well. This is Shankar. In this video, I will explain about submit vs execute methods in executor service class. So, in this video, I will explain key differences between submit and execute methods in executor service. This is the class. In that class, these two methods are available. So, let's get started. It is not a sketch video. It is the continuation video of multi-threading playlist. This playlist link I will provide in description of this video. These executor service class available in multi-threading like java.lang.concurrent package available. This concept is belonging to multi-threading. So first I will develop some piece of code. Based on that code I will so create one table and so add differences between submit vs execute methods. So let's create a one test class. Suppose class like thread test. Suppose these also we are using that pooling, right? Thread pool test. Select main method finish. So now post executor executors dot new fixed. These are multiple types are there. New single thread executor, single thread executor, new single thread scheduled executor like that. So new fixed thread pool. We want new fixed thread pool. These are the two overloaded method. We need to choose first one. So I will mention like 5. So fixed new fixed thread pool 5. That means 5 threads it will create. This here creates a thread pool that you reuses a fixed number of threads operating off a shared unbounded queue. Fixed number of threads. So you are creating the 5 threads. Suppose I have the 10 tasks, but I have only 5 threads. So the 5 threads reuse it, right? It will return see new fixed thread pool. It will return the executor service. So executor service equal to import it. It is belonging to java.lang concurrent character control shift F for formatting or pretty printing, right? So now let's add some command here. Thread pool, thread pool with 5 threads, thread pool with 5 threads, right? So some bullet points. Let's add here. So some bullet points. Assume like it is a note points. So the tasks. So the tasks run one by one. Run one by one. So serial serial execution, not not parallel, not parallel. So by using executors, we can achieve the parallel. But after developing this piece of code, I will change. So after developing piece of code, I will change. It will execute like a serial execution, one after one, one after one. I will use thread dot sleep. So by using executor service, we can achieve parallel processing. At a time, multiple threads can be executed. Is called the parallel. So so the tasks run one by one. It is called serial execution, not parallel. So the the main thread, the main thread blocks at future dot get until each task finishes until each task finishes. See, after service dot submit method, when we invoke, it will return the future this get method. It will act like a blocking mechanism. That means until completing the current thread, no more chance to execute other threads. Once it is current thread is completed, then only it moves to the next thread. Then only it moves to the next thread, right? So now, for example, for example, for example, task one, task one, task one waits 10 seconds. Task one waits and 10 seconds. 10 seconds. Task two, task two waits 10 seconds. Task 1 waits 10 seconds. Task 2 waits 10 seconds. So now let's take service, right? This is the reference variable. Service dot the execute. It will the parameter expecting runnable void method. Runnable void method, right? So let's add this point and here see submit contains three overloaded methods. Three methods. It will return the future. It will return the future. So first one is the so return type. First one is the return type void execute. It is expecting the runnable. Runnable have the run method. Run method has the void type. It will return nothing. Submit. Submit. So see if we will check submit. Submit can accept. Submit can have parameter like callable, runnable, callable, runnable. It will accept parameter as parameter like callable or runnable. So and it will return the future. So let's add command like accepts both runnable and callable, runnable and callable tasks multiple multiple overloaded methods, methods, methods there, methods there. So I'm decreasing this size and removing the bold. So remove 12, 12. So return type bold I'm keeping, just size I'm decreasing. Next, so next, next point, task types accepted. Task types accepted. So what types accepted? Execute method only accept runnable tasks, right? Only accepts runnable runnable tasks. So only one parameter like runnable tasks only it will accept. So let's copy control V. So the return type void. This is I mistakenly added here. Let's move to return type void. Submit return type future of t future of t. So here task types accepted only accepts runnable tasks. Only accepts runnable tasks. Accepts both runnable and callable tasks. Multiple overloaded methods there. So third point, result and link. Result, result, result and link. See here, result and link. Let's decrease size to 12. So does not return any result. 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 So here submit returns a future object to retro results. Return return a future object. Return a future object to to retrieve results, return a future object to retrieve results. So next point, fourth point. So let's discuss after developing some more piece of code. So now let's use the submit. So let's use the submit, right? Submit, accept, expecting the either callable or runnable. So now what we need to do, let's create the runnable. So lambda expression runnable have only one run method, right? So we can able to use lambda expression. So so standard outer println. So it is not giving any suggestion. Standard out dot println. Here we need to mention like thread dot current thread dot get name, thread dot. So it is not giving. So first let's store runnable task equal to. Now it is giving current thread. So dot get name, right? So in this node point I said I will use, so waits 10 seconds, right? To wait 10 seconds I will use thread dot sleep. I'm moving to brackets. Here I will use thread dot sleep. 10 seconds means, so thread dot sleep. So 10 triple zero 10,000, right? Now we need to pass the task semicolon. See, it is we need to handle with, we need to surround this thread dot sleep with try catch block. That's it. Now see here, let's add some command simulating simulating long running long running task. So like it will wait for the 10 seconds long running task. If any long running task is there, it will wait for the, it will wait for the 10 seconds. So now here let's use the, so for this is the third full size is the 5. I want to run 10 tasks, right? And I equal to, int I equal to 1, I less than or equal to 10, I plus plus I plus plus. Now now let's add some command submitting 10 tasks. What we are doing, submitting 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 10 tasks. So after that, but due to future dot get due to future dot get runs one task at a time, right? So it will return the future, right? Future of, suppose some generic t. So let's add future. So control shift to import. In future we have get method. It will act as the blocking mechanism until completing current thread. It will hold the remaining thread to execute, right? Future. It will also returning again. So say get method, what it will returning? It will return the object. So now throws declaration. Let's declare it is. We need to handle two exceptions. Just I am added to method level. Just we are throwing the exception. So now next add here some comments. Main thread, main thread, main thread. It is very important. Waits here, waits here until current, until current task completes, completes. So another point, no parallel, no parallel execution, no parallel execution. So select Control Shift F, pretty printing, right? So if you want to shut down, so let's shut down service dot shut down, service dot shut down control as. So this is the code I am developed. So post, let's add the port point here. First I will show the result, then you can understand very well. So 10 seconds, right? Let's run this. Right click, run as Java application, run as Java application. So wait 10 seconds, then it will, one thread will be created. See, one thread will be created. After another 10 seconds, another thread will be printed, right? Printed, created like that. So it is like one by one. It will not doing parallel, parallel. It is not doing parallel, right? See, one after one, like it is blocking. So here it is future dot get, future dot get. It is blocking. Let's comment this line. What happens then? I'm commenting future dot get. Then what happens? Run as Java application, Java application, run as Java application. So see, first five five threads are printed. Wait another 10 seconds. Then it will print another five, right? So see, now it is the parallel processing. Previously it is one by one, like serial execution. So let's have the fourth point here. Now we understand, right? Blocking, non-blocking mechanism here. Blocking, blocking behavior, blocking behavior. So non non-blocking, non-blocking does not wait for completion, does not wait for completion. So can block when calling get on, when calling get on future, when calling get on future. So 12, same 12. So again same 12. See, submit method we are verified, right? Execute, let's verify execute as well. So let's verify execute as well. I'm commanding these two lines. I'm commanding these two lines. Let's add service dot execute. It is expecting the runnable. So added. It will returning anything. It is void type, nothing it will return. So there is no future, right? There is no get. So let's call run as Java application. So because it will be void, there is no returning. So it is like a non-blocking mechanism. There is no way to block. See, first I am reading the five threads. It is parallel executed five threads. After some time, remaining five threads will be printed, right? So it is like a, let's say, a non non-blocking mechanism. Non-blocking. It is like a blocking. So by using future dot cut, we can block blocking mechanism, right? So use cases. Let's say our fifth point, like a use case. Use case. So use when you do not need a result. Need a result. You when you need need to obtain a result. Need to obtain a result. So decrease side to 12. So bold 12. 12. So see, these are the differences. We are understand programmatic way very well, right? We are understand programmatic way very well. So this program we are understand, right? I will read these 5 points one time. Key differences between submit and execute. Key differences between submit and execute. Methods in executor service. Methods in executor service. Methods in executor service. So execute return type is void. Submit return type is future. Future ta- task types accepted. So execute it will accept the runnable as a parameter. Submit it will accept the both runnable and callable. So submit have multiple three overloaded methods are there. Result handling it does not return any value because of execute method is a void. It will return the future object. In future we have a one get method is there. By using that get method we can do blocking. Blocking. So by default executor framework meant for the parallel processing multiple threads non-blocking behavior. Blocking behavior here, this is the non-blocking does not wait for the completion, so there is no way to block here, but in submit can block when calling get on future. Use cases use when you do not need a result, use when you need obtain a result. So in this video we are successfully understand submit vs execute in executor service. Key differences between submit method and execute method in executor service. Thank you for watching. For more videos, please subscribe to this YouTube channel.